Jack is walking on a hill. He passes a point A with coordinates 3,12. He next passes a point B with coordinates 5,6. Find the gradient of the hill. Is Jack going up the hill or down the hill? So this is an example similar to number question 4B in the assignment. So we're going to solve it, and then you're going to apply the knowledge here towards this assignment question. So for part 1, it's asking for the gradient. Part 1 is asking for the gradient. So let's apply the solution. We are going to look into module 9 to obtain the gradient of the formula, the equation for the gradient of a line that joins 2 points. Module number 7. So in module number 7, page 5, you can get the formula, the equation for the gradient if a line passes through 2 points, x1, y1, x2, y2. An abbreviation for gradient or slope is rise over run, meaning how much rise with every 1 unit of run. So we are going to make a copy of this gradient, this formula. Place it in our worksheet. What we need to do is to label the 2 points, the coordinates of the 2 points, so that we can substitute into the formula for gradient. So we have points 3,12, sorry, and we've got points 5,6. So we can call 3,12.1 and 5,6.2. So having done this, we can clearly label x1 because we know the x coordinate comes first, x1 3, and we can label y1 12. And then now we can label x2 5, and we can label y2 6. Okay. So in that way, we can substitute into the formula for gradient represented by the letter M. Gradient starts with G, but this letter for gradient is M. So probably because the G is used for something already, which is gravity. So the mathematicians probably say, well, the French for gradient is the French word for climb is monter, to mount, yes. So probably that's why they use M for gradient. And the gradient formula comes with a negative sign already, a subtraction sign, y2 minus y1 over x2 minus x1. We have to please take note of that. Let's substitute now. Even in case your coordinates have a negative number, you can manage it properly. So we called y2 6. So 6 subtract, but the subtraction sign is there already. So we have to be careful. So 6 subtract 12. That's y2 minus y1, and x2 is 5. Subtract y1, which is 3. So 6 subtract 12, That will give us a -6 because you try to take out 12 from 6. So you'll still have 6 more to take out. So that's taking out 6. Or you're going 6 units towards the right, but 12 units towards the left. So you'll still get 6 more units towards the left. Yes? So that's a -6. Meaning 6 units towards the left. Now 5, take away 3, taking out 3 from 5. So you're left 2. And 2 into -6 to divide -6 divided by 2. A negative divided by a positive will give us a -3. The gradient is -3. This means that with each, because with the -3, that's actually -3 on 1. Okay, so this means that with every 1 unit that you are moving x, you are moving -3 units y. Okay, so as the definition for gradient, one of the definitions. So if every unit, because remember the denominator is x2 minus x1, the way that x is changing. So when x is increasing by 1, y is decreasing by decreasing by 3. So when you interpret in gradient, you always refer to when x is increasing by 1, because when you calculate in gradient, there'll always be a 1 in the denominator. So when x increasing by 1, y is decreasing by -3. You can use that as an interpretation of gradient. Let's even write it there. So this repetition when x increases by 1. So when you interpret in gradient, you always mention x increasing by 1. Because when you calculate in rise over run, y2 minus y1 over x2 minus x1, you will end up always having a 1 in the denominator, and the numerator will be the value that the denominator went into. So 2 into 2 goes once, and 2 into -6 goes -3. So you get a gradient of -3, meaning when x increases by 1, y decreases by 3. So this ties in nicely now with part 2. It says, is Jack going up the hill or down the hill? Jack is going down the hill. Okay. Jack is going down the hill. Because when x increases by 1, y decreases by 3. Decreases mean going down.